Hello, dear colleagues. Let us start our session. Although there's not much people in the room, but I hope they will join us. We have two speakers. The first one is going to talk about substitution potential for wood fibers. Is Nuno Silva. You have the curricula on your application with all the details, but I will make it simple and quick, saying that he's a biochemist whose research bridges fundamental biophysical principles and applied biotechnology. He has been in the Minho University, as some postdoctoral positions in Germany and Netherlands, has got a PhD in collaboration with Cleveland Diagnostics in US, and now is back to Minho University, working on sustainable industrial processes under the From Fossil to Forest agenda. Nuno, please, stage is yours.
So, good afternoon, everyone. It's a great pleasure to be here and be able to share a little bit of the work that we have been developing regarding the upgrading of the mechanical properties of paper at the University of Minho. So, this work is part of the From Fossil to Forest agenda, which is a result of the Recover and Resilient plan co-financed by the EU, aiming the development and the adoption of paper-based and sustainable packaging to completely replace fossil plastic packages. So what brings us here, it's not only the paper, but also our biggest enemy, the plastic. So you must be familiar with these numbers, but I will just refresh your minds. So in the 2018 United Nations Environment Programme report, it was concluded that every year in the world, 400 million tons of fossil plastic are produced. And also, from this plastic, around 80% of plastic waste is generated and ends up in landfills or simply dumped in the environment. And only 9% of this plastic is recycled, with only 1.3% being effectively recycled. Also, what was very interesting in this report, it was that the packaging sector was identified as the main consumer of the total plastic produced in the world, and also the sector who generates more plastic waste. So in order to mitigate this fossil plastic issue, the European Commission launched in their new Circular Economy Action Plan of 2020 a set of measures and actions to force the reduction of the consumption of fossil-based plastics, and also reunited a set of measures promoting the adoption of novel, eco-friendly alternatives, such as the use of paper. As you know for sure, paper and cellulosic fibers derived from wood, they stand out as one of the most promising and interesting materials, mainly due to their biodegradability, recyclability. But however, despite the industry of the packaging in this case has already been moving towards the use of paper-based alternatives, the truth is that the challenges for the paper industry right now, they are still related with increasing, for example, increasing the recyclability of paper-based products, and especially produced paper with better mechanical and barrier properties. So as I mentioned, develop or produce paper with better mechanical properties is the main goal of our agenda. And the idea is to, so our work and our idea is to develop paper with enhanced mechanical properties such as burst, tear, and tensile strength, among others, to ultimately produce 100% paper-based packages in order to force the market and the industry to move from plastic to completely paper packages. So in our work, we have been using unbleached kraft pulp provided by the Navigator company. And our first step was to select different polymers, natural and synthetic polymers, from a vast set of molecules belonging to different classes, but mainly polysaccharides and carboxylate polymers. And for this selection, we use the biodegradability of the polymers, their non-toxicity, and their previous food contact approval as main selection criteria. And then, when it was possible, we also included in our polymer testing list some variants of these pre-selected polymers that presented different physical-chemical characteristics, such as different surface charges, or structural modifications, such as different functional groups that we consider to be relevant for the interaction with the cellulose fibers. These polymers that we selected, they were used as wet end strength additives, and before we indeed evaluate their performances on enhancing or not the mechanical properties of the paper, we performed some preliminary experiments to first optimize, to understand how to prepare and how to handle these polymers, also to identify the most suitable point to add these additives to our paper furnish, and then, of course, some experiments to determine what would be the best concentration range to use. And finally, we also explored the combined use of these polymer additives with some standard retention aids. And it will be the last example that I will show you. We also explored the combined use of different polymers so that we can have in our formulations only these biodegradable alternatives. So in our first round of experiments, we wanted to validate and to check if the polymers that we have selected, they were indeed suitable for this application. So due to an NDA, I can give you the right names of the polymers that we have used, so I will ask you to believe me. And trust that each of these colorful bars correspond to different polymers, and the results here for the different mechanical properties that we have assessed, the results are presented as increasing percentages, so the variance of the absolute values measured comparing to a reference paper, which in this case was paper without any additives. So we were very surprised to see that from our selection, only one of the polymer was was unable to lead to increases on the mechanical properties of the end sheets. So our pre-selection, our criteria was quite successful. But then we wanted to further investigate and explore the use of these polymers. So we took two of the most promising polymers from the round before, and we explored different concentrations of each one of the polymers. And we also explored the pulp consistency. So these additives, these polymers, they were in contact with the paper furnish at different concentration points, let's say. And what we observed, it was that for both polymers, increasing the polymer concentration and also have the polymers in contact with more concentrated pulp, so pulp with higher consistency, led to higher and significant increases in the mechanical properties. And for us, a significant increase would be something higher than 5%. So then we wanted to explore how the charge of our polymers would be an important aspect to have in mind when using these polymers as wet-end additives. So we used three very similar polymers in their structure, but presenting different surface charges. So one was positively charged, another was negatively charged, and we used one amphoteric. And surprisingly, at least for us, we observed that the cationic polymer had the poorest performance, while the amphoteric polymer was the one presenting, at least for the majority of the indexes evaluated, the most significant performance. Then we took again the two most promising polymers from our selection, and we evaluate the combined use of these polymers with standard retention aids. And what we concluded from this experiment, it was that when we have both types of additives in our formulation, we were able to overcome some of the negative effects of the common associated to the retention aids. However, for the tear index, we couldn't see any improvements. And then, what was our most challenging, but also the most important experiment, we try to combine two different polymers and see if having only these two additives in our formulations without any other type of agents, if we could see even higher changes in our in the mechanical properties of our end sheets. And we did see a better performance when we have two polymers, even when we used non-optimized and very low concentrations of these polymers. And these are the first two bars of these plots. But we were very surprised when we saw that when we optimized the ratio of these two polymers, we were able to obtain very high improvements in all mechanical properties, and especially we were able to obtain 15% increasing in the tear index, and at the same time an increasing over 40% in the burst index, which for us was extremely important. So just to give you a final and a quick overview of our data, if we consider the CEPI guidelines and or criteria for the definition of the different paper grades. And if we look for our most promising paper formulation, we saw that with our strategy of using natural polymers to improve the mechanical properties of the paper, we were able to not only meet but also suppress the minimum requirements to produce paper belonging to the brown kraft liner and the brown test liner grades, which is good for the packaging sector. So finally, my last message to you all is that the answer to stop the excessive fossil plastic consumption can rely entirely in nature, from the cellulose fibers to produce the paper to the biopolymers that we can use to produce paper with enhanced mechanical properties that can be used to produce new eco-friendly packaging solutions. So with that, I would like to acknowledge all the team members from the From Fossil to Forest team from Uminho, also the members from the Raiz Institute and the Navigator company who have helped me during this project, and of course to you all for your attention. Thank you.
Thank you, Nuno. We will leave the questions for the end. And now we have another presentation by Lari Lampila. And again, trying to make a small summary of half of a lifetime, as he said recently, dedicated to run-tech systems, especially to these vacuum systems, but with a lot of experience worldwide, more than 30 countries around the world dedicated to removing the last drop of water from the webbing forming. Thank you, Lari, please.
Yes, hello, my name is Lari Lampila, and thank you very much for having me here, and it's nice to have a speech to you about this, our findings and products and so on. I hope I can have a pointer in here somewhere. Yes. So in Rantec systems, we are specialized not only in a vacuum system, but we have a lots of different know-how around from the wet end to the dry end and everything in between. And nowadays, more and more different system integration inside the paper machine. Why should we ask or talk about these speed-controlled turbo blowers and vacuum sources? One reason is, of course, that this is very rarely known, but the European Union is regulating this technology, and one of the requests for the new paper mills, paper sites, is that they need to use this kind of a best available technology. And speed controlled turbo blower is proven to be one of those. So this is something that is good to keep in mind when designing the new sites and the major rebuilds. What can we gain with this speed controlled machines is savings with the energy is normally from 25-30% up to 70%. It's depending on how much we are integrating this and how much we are optimizing the system. We are not using water. These are dry systems, so this is one huge benefit, especially for the areas where you have limited water sources. Due to lower energy usage, of course, CO2 emissions and a smaller carbon footprint is that way achieved as well. Variable speed and capacity, quick optimization without needing bleed air, and minimal throttling and expansion losses. So some cases we are, or can be built the whole vacuum system with one big blower, but these sometimes are ending up into the situation where we are creating expansion losses when we are mixing high vacuums and low vacuums together. That's why our approach of having several blowers with the different vacuum levels and adjustable capacity is much better from that point of view. After being auditing paper machines around the world for the last 30 years, we have been gaining this kind of a database for all major paper grades. For example, this is from tissue making. This is showing all the machines that we have been auditing, and then these green ones are showing the level of energy usage with the machines that we have been optimizing with our blowers. And we can see clearly that with this kind of speed controlled blowers, we can create what we are calling best practice level in here. And we are creating that kind of a benchmark that where's supposed you to be with the specific energy consumption, kilowatt hours per ton. So of course it's good to be here rather than here. If your competitors are here, it's not good to stay in here and give a head for as a higher energy consumption. Blowers, what we are producing are having from 0 to 100% capacity, so we can operate the full range of the different rotation speed. So we don't have any kind of forbidden frequencies or anything like that. So we can fully utilize the whole capacity of the blower from the very small RPMs up to the full speed. That's all available. This total motor that we are using is designed for the variable speed drive, and this is one reason why we can use the whole capacity. It is not kind of a modification for the standard motor where we can facing these critical frequencies, but it started already from day one that we needed to have the full range available. Our units are integrated very heavily, so motor is inside, and this is giving a big benefit, especially in the rebuilds. But also when we are talking about green fields, that we don't have to make such a big pump rooms, and the footprint of the system is much smaller. That way the total investment is smaller. There is no gearbox because everything is directly on the shaft, and this is one thing that is giving also this space requirement benefit, that one device less and also several points for the maintenance less. Maintenance is that way very simple, as the mechanical construction is very simple. So there is only one rotating shaft and two bearings in there. There we can see that when we are designing the blower correctly into the system, we're supposed to be in more or less in the middle of the operating range. So that way we can go up with the rotation speed and having the higher vacuum levels, or we can going down to have a lower one. And then also in a flow direction, we have a flexibility in both directions. And this flexibility is something that is really, really important when we are talking about the optimization of the system. This is showing the difference when we are comparing different vacuum sources. So we have here a fixed speed blower, then we have a variable speed blower, and then we have a liquid ring pump. So airflow on a x-axis and vacuum on a y-axis, and where the liquid ring pump is having always almost, well, it's a fixed flow pump, so the flow is always the same, more or less the same. And according to what is the restriction in the end of the pipe, ceramics, felt, wire, what kind of a paper pulp is used, it's affecting to how much vacuum is created in a system. Blower is totally different. It's having all the time almost same vacuum level if we are rotating on the same speed. But then according to the flow or restriction, the flow can vary a lot alongside this curve. And if we can have a variable speed blower, then we can basically have these curves as many as we want. Every single RPM is a independent curve, which is meaning that we can operate on this whole area. It is not a curve anymore, but it's the area. And this is giving a lots of benefits when it comes to the kind of a flexibility in capacity, and also adaptation from the different operational points that is coming from the different production and the different age of the felts and wire and so on. Here we can see the same for example, that if we are keeping the same 50 kilopascal vacuum level, for example, on a vacuum suction box, in a startup, we get lots of air there coming because the felt is open and new. When we are agenting with the felt, we are moving this line into the left on the curve side, and at the same time the airflow is reducing. And as with the blower, power usage is going hand in hand with the kilograms. So starting point with the new felt, 580 kilowatts, with the old felt, 255. This is also one thing that is good to keep in mind, that when we are having a new paper machine specification, and very often these specifications are, well, overdimensioned a little bit. There is always extra capacity for every single stage, and this is meaning that it can be very challenging from the device point of view if the specification is very high, but in the end the operational point is very different from that. And with our systems, this is not so big problem when we have several smaller units and the full flexibility about this area where we can operate. So this is, for example, one specification from machine builder, where the original specification was -45 and 9 cubic meters per second. This is going basically hand in hand with the single or 1.5 size tissue machine. In the end, the operational point was 25 kilopascals and only 2.5 cubic meters per second. So we came quite a lot down with the kilopascals, and also huge drawback with the flow. But no problem with the blower. Blower is adapting into here very easily, and this was not a problem. We didn't have to do any mechanical movement or changes, just the settings in a DCS. The system is built so that in a basement, as normal, as in any pump room, we have turbo blowers and separators. Then they are connected to the mill, to the paper machine in a different positions. We have water pre-separators and drop separators in every stage, and then control valves. Sometimes we are sharing capacity with the intermediate valves. We are measuring the water that we are extracting from the process, and this is also one important part of the operating this kind of adjustable system. More and more important also is that when we are doing a compression here at the blower, we are creating hot air in the exhaust. And this hot air is more and more utilized in a drying hood, in heat recovery systems, and so on. And that way we can get all the energy recovered from the vacuum system. And also this is integrating the vacuum system more and more into the other part of the machine. Press section dewatering and also wire section dewatering is very important part of the vacuum system. And if we press section is maybe easier to understand and explain, let's say. The purpose of the press section is purely about the dewatering. It's about taking the water out from the web. So why do not we measure all of this water? And according to this dewatering information, we can then adjust the vacuum that is needed in each position. And I think that this is one of the key ideas of this adjustable vacuum system, that we need to have information how we are adjusting the blower. We need to get that information from the process, and that kind of a reliable information that when we are making the adjustment for the vacuum, we can immediately see from the dewatering measurements that what is going on. Was the adjustment, was it good for the process, for the dewatering, or was it bad? Then in a DCS, we can put everything into the table, every single positions, and then have of course the total of the dewatering from the press section. And whatever changes or movement we are making here in a process, it's affecting into this value. If it was a positive change, this is going up. If it was a negative, then this is going down. And this is a good tool for justifying the adjustments on a paper machine. When we are connecting together with the one blower several positions, then we are creating kind of a throttling system into the pipeline. And this system is working so that whichever from these single positions, it can be a Euler box, flat section box, roll, couch roll, press section roll, whatsoever, whichever is having the highest set point, this is working as a muster for the blower speed. And blower is speeding up to create this maximum vacuum level. Of course, this control valve is then forced to 100. And then all the other branches into the blower are then working as independent control loops with a throttling valve. And this way we can mix different vacuum levels and operate only with one blower. What is the kind of a future, or actually it's not anymore future, it's today technology, is active magnetic bearing technology, and this is coming very heavily into our business, and the main purpose is, of course, is that we are trying to minimize the maintenance that we are doing for the blowers, and this active magnetic bearing is that way very good, that basically we don't have any more mechanical contact in the bearings, and there is nothing that can be wear out. There are, of course, kind of a safety bearings if something is happening to the magnetic field or power field or so on, so that there is a mechanical backup, and this is maybe something that we need to every now and then change, but otherwise this is increasing the maintenance interval quite a lot. All these kind of things like dirty build-up and other things, these are remaining, of course, the same, because the blower itself doesn't change. Only the bearing is changing there. Another thing is what we have been starting to use nowadays is open impellers. There we can see that the impeller is not more like a closed one, like in some process pumps, but it's having the open wing plates. And this is a beneficial when it comes to the build-up of the dirt into the impeller. So there is less place less area where the buildup can be sticking. And this kind of a impeller is also much easier to clean. So when we are doing the maintenance, the cleaning of the impeller is much easier. If we are comparing the ball bearings and or the kind of a conventional bearings and maglev active magnetic bearing, we can see following things: that ball bearings very high bearing stiffness and strong resistance against the impulse forces, low friction and low running losses, all lubricated, simple construction and very proven construction. You can find ball bearings wherever. But it requires maintenance. In our case, it's every 18 months. And it has a limited capacity to handle unbalance, because the mass center line and the geometrical center line supposed to be the same. But when we have a build-up, these are different. So the mass center line is different then. And there is a limited capacity to handle this one. So vibration level is then making the limitation. And it's widely used. It's a lower investment. But then what benefits we can have from the maglev is well, low bearing stiffness, limited impulse for capacity. These are little bit drawbacks, but nothing major. So far our experience is that they are giving us no weakness in the system. But at the same, no mechanical friction. So there is nothing that is wearing out. There is nothing that is causing friction. There is no need for the lubrication. So we don't need any oil changes. We don't need oil filters and this kind of a, let's say, every month, every year maintenance. It has a separated control system. It has a backup bearings that has a certain change interval. But it has also very high capacity to handle unbalance. And this is very interesting thing, because we can orbitating the rotor. So the mass center line and the mechanical center line don't have to be the same. But we can make a kind of a barrel movement or pipe movement with the rotor, and that way you don't see vibration increase in the magnetic bearing unit, because there is no vibration. The orbitating diameter is compensating this imbalance, and that way actually what we are following, if we want to understand that is there imbalance, is the diameter of the orbiting. This is of course a new technology in pulp and paper, and a little bit higher investment, but for sure, very interesting new technology, and for sure it will be the future solution. Right now we have 2 places where we are running with this one tissue machine in Turkey, and that has been running already 3 years there without any problems. And we are right now rebuilding one liner machine in Germany, where we are replacing 12 liquid ring pumps with the 7 turbo blowers, and major force, of course, for this is energy saving, but also this maintenance savings. Summary quickly: measure with the dewatering measurement, control with the blowers, and recover in sables. And high vacuum is not high productivity. High vacuum is always high cost. Thank you very much. Sorry I was maybe a little bit over time, but...
Thank you, Lari. Thank you for your presentation. We are a bit short of time, but still for a couple of questions, if any. Please, the microphone there.
Yes? Okay. Thank you very much, both, for your presentation. It was very nice. Okay, I have a question. I am Luis Tunzunegui from Belmer Iberica, and I have a question for Nuno. I was thinking in your presentation and your test about using these new polymers, and you are thinking always to use paper as plastic, no? And thinking in what strengths improve the quality and strengths in general. What about recycling this paper? Did you think in it? Or because usually, only to say you, it is very difficult to repulping this new paper that are they have a big battle against to the water, no? And actually for the recycling people, paper mills in general, today they have more difficulties for recycling the typical OCC, no? Okay, it's a little bit this is the question or idea that is running in my mind, nothing more. Thank you.
You can hear, right? Yes, I think you can. Thank you for your question. So yes, the recyclability is one of the things that we for sure will evaluate later. Right now we are not especially concerned about it, since the best formulations that we found were indeed with biopolymers, and those what I can say without revealing too much. So their structure really resembles some natural polymers, so in principle the recyclability of the paper in the end will not be really affected, but it is part of our agenda, so it's not part of my work, but from our other partners in the project. They will indeed evaluate both, and besides we are using all our polymers are biodegradable. They will also evaluate not only the recyclability but also the biodegradability of the final paper produced.
Only I need to wait, no, for your college study.
Yes, but we have already some preliminary data on that regard, because with one of the polymers that we have tested, and recyclability was not negatively affected. So we have good indications that at least our approach and using these polymers will not affect the recyclability.
Okay, we'll see. Thank you.
We have one question there, please.
Hello, José Oliveira from Altri. One question for Lari. You were talking about the use of vacuum pumps in paper machines. What about pulp applications, pulp dryer machines, and also other uses like disc filters in the...
Yes, in that way, turbo blower doesn't understand if it's connected to the pulp machine or paper machine or tissue machine. So we have several references in the pulp drying machines as well. Really in the pulp making process, we are not going, because in some cases higher vacuum levels are needed and temperature is high and very aggressive environment. So there we are recommending liquid ring pumps still. But the pulp drying machines, yes. For example, in Ence, in northern Spain, we have 2 pulp drying lines which are running with our blowers, and also in Finland we have Enocell that is running with our blowers.
Okay, I think we have no more time for questions. Thank you very much. One comment: your abstract in your documentation has nothing to do with what you presented us. So don't be surprised, because that's something else. But it was a good presentation, both of you. Thank you.
Thank you very much.